Okay, now okay. Okay, this is our seventh lesson, mechanical properties of matters. Mechanical properties of matters. Mechanical properties of matters. Okay, what's the meaning of mechanical properties first? Okay, last lesson we discussed about in work energy and power lesson, we discussed about mechanical energy. I told it is not a property, it's a energy type, no? The mechanical energy is a energy, it's a type of energy stored due to object position or object motion. This definition is important, you have to remember. Okay, now what are the properties? Property mean characteristics, no? The characteristic of any matter. It is not energy type. Last recently we discussed about mechanical energy. That's an energy type. That's an energy type. This is not energy. In this lesson, we are mainly discussed about properties. 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 Okay. What are the meaning of properties? Properties mean actually what? Properties mean actually characteristic. Characteristic. යාළඟ තියෙන ලක්ෂණ කියලා අපි කියනවා. අපි කියන properties ගුණාංග කියලා. හරි. Okay, what are the types of properties of any matter? This properties of any matter we can divide into three main categories. අපිට තව divide කරන්න පුළුවන් mainly three types. Mainly three types. The first one is physical and chemical properties. Physical and chemical property of any matter. Physical and chemical properties. Physical and chemical properties. Physical and chemical properties. What are the physical properties? The thermal, the physical property, expansion, subtraction, they are physical properties. What are the meaning of chemical properties? Chemical characteristics. Chemical characteristic that we discussed in chemical kinetic chemistry. In the lesson kinetic chemistry, we mainly discussed about chemical properties of any matter. Chemical properties of any matter. Physical properties we mainly discussed about mainly discussed in heat lesson, our physics lesson. Okay, the second property type, electric and magnetic properties. Electric and magnetic properties. Electric and magnetic properties. Magnetic properties. Both property types we discussed in the electricity lesson. In electricity lesson, there is a separate part that we called as magnetism. Magnetism, Fleming's left hand law, Fleming's left hand law, Fleming's right hand law. We can use to understand this magnetism. That's we discussed about magnetic properties of matters. Magnetic properties of matters and electric properties of matters. Conductors, semiconductors, insulators, they are the electric properties. Electric properties, that means electric conducting ability, right? There are different types of properties in matters. What's the meaning of matters? Do you know what's the meaning of matters? You meant what's the meaning of matters? Matter එකක් කියලා කියන්නේ. Now properties, you have idea, different property types. Yes, has a mass and very good. Simply, matters are gas, solid and liquids. gas, solids and liquids වල තමයි අපි matters කියලා කියන්නේ. Matters. Normally physical state, three physical states of matters. Solid, gas and liquid. එතකොට අපි ගත්තොත් any object. Now this is a matter. That's a solid object. Solid object. If you got water cup, it is a liquid object, liquid matter. Okay, everything in our earth, solid, liquid and gas are the matter. Solid, liquid and gas are the matter. Yes, we are correct. Has a mass and it occupies some space. Yes. Yeah, they are the properties, and we are discussing properties of matters. A matters වල තියෙන properties, characteristics. Okay, the first one is physical and chemical properties. I told in our future lessons we can discuss about them. Electric and magnetic properties. In electricity lesson we are discussing about electricity and magnetism both. Our third property is the mechanical properties. Mechanical properties. In this lesson we mainly discussed about these mechanical properties. Mechanical properties. Mechanical properties of matters. In this lesson, our target to discuss about basics of mechanical properties. We are discussing with a basic level of about mechanical properties. I think in O level time you didn't have, no? Didn't have any lesson as mechanical properties. Elasticity, non-elasticity, extension. No, that's a new part. That's why we are doing very basic level. Okay, basic level. Okay, let's move into tooth. Okay, mechanical properties of matters. The study of matters often involve categorize its properties into three main types. For our study, we can categorize into three main types: electric properties, physical and chemical properties, and mechanical properties. This lesson, we mainly focus especially on mechanical properties of matters. That's the target of this lesson. Mechanical properties of matters. Okay. Now, what is the meaning of mechanical properties? Now, I think you have idea about what's the meaning of physical properties, chemical properties. Can chemical changes with the properties change? Now, what is the meaning of mechanical properties? Mechanical properties. What's the definition? Remember, the mechanical properties mean, think this is the object. This is object. If I apply in tension force or compression force, that we call as tension force. Tension force. In lesson we can discuss tensile force. Tensile force. Tensile force. This tensile force means the length increasing force. The length increasing tensile force. අපි මෙහෙම compress වෙන දෙන එකට අපි කියන compression force. Compression force. Compression force. Compression force. Compression force. Okay, when we apply compression or tensile force on any object, how to behave this object? They are the mechanical properties. They are the mechanical properties. This is the definition. The definition given in the theory. The mechanical properties describe how material respond, how to behave when an external force is applied. The external force can be a tensile force or compressive force. Tensile force or compressive force. Okay, up to now, okay. We discussed only 3 points. in the mechanical properties, physical properties, chemical properties, electrical properties, magnetic properties that we can discuss in our future lessons. In electricity, heat, duct, those lessons we can discuss about other properties. In this lesson, we mainly discussed about mechanical properties. What's the meaning of mechanical properties? When we apply tensile force or compression force on an object, how this object behave, how to respond for this force. That's the meaning of mechanical properties. That's the meaning of mechanical properties. Highlight that. Okay, that's important. That's the meaning of mechanical properties. They are the example deforming, stretching, compressing, bending, breaking. They are the responses. Okay, actually they are the mechanical properties. Okay. In mechanical properties, sorry. Okay, again revise what's the meaning of mechanical properties. When you apply tensile or compressive force on any object, the behavior or response of the object we called as a mechanical properties. Okay, what are the mechanical properties? They are the mechanical properties actually. Mechanical properties. Wait, I will show you. Yeah, the ductility is a mechanical properties. For your additional knowledge. Okay, ductility. The ability of a material to be stretched into a thin wire, as a thin wire, that we call as ductility. Malleability. The ability of a material to be hammed or rolled into thin sheet, that we call as malleability. Brittleness, the tendency of material to break break the tendency. Glass, ceramic, they are breaking easily, right? Toughness, the ability of any material to absorb energy and deform plasticity before breaking. Okay, the ability of retention, that's we called as toughness. Retain toughness. Hardness, the resistance of a material to strength, so stretching and adhesion. Okay, hardness, the diamonds and hardened steels. Okay, you don't need to buy hard them for your additional knowledge I have given. Okay, they are the mechanical properties. And strength, the ability of material withstands applied stress without failure. It can make a break in retention the strength can. Okay, they are the mechanical properties. When we apply external force, how to respond? Okay, what are the examples? Ductility, malleability, brittleness, toughness, hardness, strength. Okay, they are the mechanical properties. And in this lesson, we mainly discussed about elasticity and inelasticity. The elasticity and inelasticity also two mechanical properties. Actually two sides of one mechanical properties. Elasticity and inelasticity. In this lesson, we mainly discussed about elasticity and inelasticity of any object, of any matter. Okay, make අපි discuss කරන main mechanical property එක තමයි elasticity and inelasticity or elasticity and plasticity කියලාත් කියනවා. Elasticity and plasticity. Okay, now come to topic, the elasticity. Okay, what's the meaning of elasticity? What's the meaning of elasticity? Do you have any idea? What's the meaning of elasticity? Okay, what's the meaning of the ability of a material to undergo temporary deformation when the force is applied and return to its very good. Very good. That's the elasticity. Others, Humet, what do you think? What's the elasticity? Give me a few seconds. Give me a second. Okay, others, do you have any idea? What's the meaning of elasticity? No? Tinu? Okay, this is actual elasticity. Elasticity, now it's a rubber band. Okay, now I have applied a force. I have applied force. If I release this force, now I have applied tensile force. Tensile force now I'm applying. Now it is deforming, right? The length increasing. The length increasing. But if I release, what happened? If I release, it's come to the same position. Same position. Okay, this is the simply the elasticity. When we apply external force, the shape is changing. It's deforming. And when it is released, what happened? It come to its original position. Okay, tell me, is it unlimited? Is it unlimited? May elasticity. Then rubber, this is material is rubber. Do you think rubber elasticity unlimited or limited? You meant the rubber is the material. The rubber elasticity unlimited or limited? Yes, definitely. Maybe now I am going to increase the applied force. Now think, I have applied force on this part. Okay, I'm going to increase the force. I'm going to increase again. Again increase. Now what happened? What happened? The thickness of the rubber band. See the thickness. Thickness of the rubber band become very less. Very thin now. Very thin. Very thin. Okay, if I release now for this small rubber band, we can observe our naked eye. If we measure, actually it has an extension. Extension mean permanent extension. Permanent extension. And again, if I applied force increase again and again, what happened? The thickness again and again decreasing. Thickness decreasing. Finally, break. Okay, therefore any object elasticity not acting unlimited pace. It's working in a limited force, only for limited pace only for a limited pace. Okay, see the definition. The elasticity, the ability of any material to deform when an external force applied and return to its original shape once the force is removed. Okay, this is the definition. Please highlight this. The ability of any material to deform when applied external force, and when it is released, it's again come to original position. Then they are elastic matters. Okay, what are the example? Okay, I have doubt now. That you given the natural wood is elastic. Are you agree with this? Natural woods, normal lean woods, are they elastics? Are they elastic? Are you agree? You met Dino? All are not agree, but natural woods are elastics. Elastic mean then don't think about like rubber. Rubber elasticity range is greater, but not unlimited. The elasticity range of rubber, it's a huge value compared to the other materials. But not only rubber elastic, other matters also there. Elastic matters. Okay, the natural woods. අපි දැන් මෙහෙම ගමු. පොඩි wooden piece එකක් ගන්න. Take a small piece of wood. අපි leaf පටියක් ගන්න. පොඩි strip එකක්. Then you can bend it, right? නමන්න පුළුවන් නේද? If you release it, again come to original position. Then it has a elasticity, but it is up to certain level. After this limit, what happened? It's breakdown. Then आप මෙහෙම ලී පටියක් අරගෙන මෙහෙම නැමුවොත් මොකද වෙන්නේ? It's bending and release, again come to original position. But if we increase the force, what happened? It's breakdown. Rubber also same thing. Rubber also the elastic properties are working only for a certain range. Understood? හැබැයි මේ natural woods වල මේ තරම් නැහැ. The natural woods elasticity range less than the rubber. Rubber elasticity greater, has a greater range. I got then metals you can, I think you can agree, metals they have some elasticity up to certain level. Okay, do you think glass? Yeah, glass. What do you think? Are they elastic? Actually, glass also elastic, but elasticity range very low. Elasticity range very low, but they are elastic. Okay, in elasticity discussion, you can understand what are the examples for, you can compare. Okay, glass also elastic up to certain level, Natural rubber, everything, you now you saw. Okay, real life example, a rubber band stretch when pulled and returns its original length. Okay, they are the elasticity. Okay, now come to next part. What is the meaning of plasticity, or if not inelasticity? Okay, the ability of matters, the inelasticity mean opposite side. When we apply external force, it's deforming. But if I release, it's not come to again into original position. It's not come to original position again. Okay, that's the meaning of inelasticity. Inelasticity. Okay, the clay and papers and cardboards, they are examples for elasticity. Now it's a paper, right? Paper. Now it's a paper. Now I am going to bend this like this and release. Is it come to original position? Okay, that's the meaning of inelasticity. අපි ගමු clay එකක්. Think about clay part like this. Okay, I'm going to bend this. Is it come to original position? No any change. Okay, take a cardboard piece and bend it. No any reaction. No again come to original position. I got the difference. Vihanger? Okay, that's the meaning of inelasticity or plasticity. Clay, paper, plasticity, and cardboard. Some type of polymers also plasticity. They have some plastic types. Only for some plastic types. සමහර ඒවාගේ තියෙනවා elasticity materials. They we can discuss in the polymer lesson. Okay, that's the base. Elasticity and inelasticity, they are the main mechanical properties. තව තියෙනවා, that's not only mechanical properties, තව තියෙනවා, but only you need to remember what's the elasticity and what's inelasticity and what's the difference and examples. Okay, they are the base. Now we are going to discuss basic concept or fundamental concept of mechanical properties of matters. The fundamental concept. Okay, the first concept, the first subtopic, elongation, the same thing, extension. Okay, what is the meaning of this extension? What's the meaning of extension? What do you think? Extension, extension, extension. Okay, the extension mean very simple thing. Extension. The extension mean, think this is a rubber string. This is a rubber string like this. හරි මේ වගේ rubber එකක් මම ලොක්කොට ඇඳලා තියෙන්නේ. This is a rubber string. Now think it is L1. The initial length L1. Initial length L1. Okay, now I'm going to apply an external force on this. External force on this rubber string. I'm going to apply on an tensile external force. Tensile force එකක් තමයි මම දෙන්නේ. Then what happened? The length increasing or decreasing? The length increasing or decreasing? Increasing. Yes. The length increasing. Okay. After when apply this external force, the length increase up to this level. Up to this level. This total length we called as L2. The total length after applied external force. Okay, that we called as the increasing length we called as the extension. As example, now this is the initial length. This is the initial length. I'm going to apply external force. Think initially it is 5 centimeter. 5 centimeter. I'm going to apply external force. Finally, it is come to 8 centimeter. Now, what is the extension? What's the extension on this string? Do you know? Initially 5 centimeter. Now, I am going to apply external tensile force and increase up to 8 centimeter. It is 3 centimeter. The increasing length when we apply external force, the increasing length of any elasticity object we called as the elongation or extension. Remember, the simple E is the symbol. Simple E, not capital E. Elongation. Okay, when a force is applied to a strength of an object, its length increasing. The increasing length we called as the elongation or extension. The increasing length in the of elasticity object we called as the extension. The delta E is the extension. Okay, how to get this delta E? Not delta E. E equal delta L, no? Length difference. The length difference equal L2 minus the final length minus initial length. Final length minus initial length. Okay, that's the story. Okay, you have to remember, okay, for our middle parts of the lesson, very important is basic concept. Okay, today actually we are discussing about basic concept, but for our important calculations and develop a relationship among them, this basic concept very important. Okay, now what's the meaning of elongation or extension? The increasing length, actually not increasing only, increasing or decreasing. Sometimes if we apply a compression force, it's decreasing. Okay, it's decreasing. Okay, then you can modify this equation, the increasing or decreasing length when we apply force on any object, tensile or compressive force on any elasticity object. That's the meaning of. However, the length difference, remember, delta L, the length difference, or delta L is the extension. Okay, up to now, understood? Okay, final length and initial length. Actually, the length difference that can be increasing length or decreasing length when you apply external force. Okay, what is a unit now? What's a unit? You told as centimeter. Yeah, we can use centimeters, but remember the standard unit is meter. SI unit is meter. The extension SI unit meter. It's a length, no? The length measuring is standard unit meter. Okay, that's why we called as the standard unit is meter. Okay, that's the first concept. What's the meaning of extension? That's extension. Okay, that's an example. Okay, this is a elongation. This applied force for extension. Okay, next concept. Next concept. Next concept. Yes, the extension done. The second concept, strain. Strain. The symbol sigma. Sigma is the symbol. Okay. Strain. What's the meaning of this strain? Now I told previously the same example. The same example. This is the rubber string. Rubber string. When we apply external force, this is L1, the initial length, and length increasing up to this level. If we think length increase up to this level, that we called as extension, right? The delta E, sorry, delta L equal to E extension. Now this is a final length L2. This is a final length L2. This is rubber string. Okay, remember the strain mean very simple thing. The strain mean according to the initial length, how many extension take by this string. හරිද? ඒ කියන්නේ මෙයාගේ මුල් දිගට සාපේක්ෂව according to the initial length, relevant to initial length, how many extension take by this material. Okay, how to get this value? The strain equal, very simple, we call the strain is the ratio between extension mean E, right? Extension and initial length. Initial length. Okay, strain equals sigma, extension E or delta L, initial length L1. Okay, remember the E over L1 is the strain. Extension, the ratio between extension and the initial length. The ratio between extension and the initial length. Okay, this is the simple equation of the extension. Sorry, strain. Strain measure how much body deformed relative to its original position. Yeah, that's why I told. This definition is very important. Relative to its original position, how about the deformation? How about the extension? Okay, that's the relationship is the strain. The ratio between extension and initial length is called as a strain. Okay, that's how calculate. That's how it calculates. Okay, what do you think? What is the unit of the strain? What's the unit of the strain? Strain unit. What's unit? What's the unit? Dinul, what's the unit? What do you think? What's the unit of the strain? SI unit. Yes. What is the extension unit? I told extension is standard unit meters. Okay, what is the L1 standard unit? It's a length. Length, what is the standard unit? Meter. Then meter to meter cancel out. No units, remember. Strain, no units. No units. Strain don't have units. Strain don't have units. Okay. Okay, let's move into third basic concept in the mechanical properties of matters. The third one is the stress. 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 This is a symbol. Stress. Stress. Okay, what do you think? What's the meaning of stress? Actually, stress කියන්නේ මොකක්ද? දැන් අපි mind එක stress වෙන එක නෙමෙයි. That's mechanical. Any object, what's the meaning of stress of any object? Remember, the stress mean the do you remember the pressure? What's the meaning of pressure? In O level time, pressure කියලා කියන්නේ මොකක්ද? Pressure. You met? Do you remember? What's the meaning of pressure? P. Yeah, very good. Force applied on unit area. Actually, in O level එහෙම කිව්වට දැන් අපි in fluid mechanism we again discussed about pressure. Actual definition: the perpendicular force applied on a unit area. Oh, perpendicular force. Perpendicular force applied on a unit area. Perpendicular force applied on a unit area. Okay, when we apply perpendicular force on a unit area of elasticity object, that's the meaning of stress. Understood? The perpendicular force applied on a unit area of an elastic object, on an elastic object, that we called as a stress. Stress. As example, now it is a rubber band. If I apply perpendicular force on a unit area like this, that's a stress, not a pressure. Pressure matama, but that we called as stress. I got. Up make it pressure killer. That is stress. The stress. The stress. Okay, then the same definition, but the stress on elastic object. The stress on elastic object. Okay, then how to calculate the same equation? The stress equal perpendicular force over area. Perpendicular force over area. Okay, this is the meaning of stress. In symbols, stress equal perpendicular force F over A. The F over A is the equation. Okay, do you know what is the unit of stress? What's the unit of stress? What's the unit of stress? No. Yeah, Pascal can, but that we not use in stress. The same unit, they use Nm minus 2. The same thing, Pascal cannot pull on. But Pascal mean the pressure found scientist name, but it is another theory. Therefore, we use Nm minus 2. Nm minus 2, the same unit, because Newton divided by square meter. Newton divided by square meter, Nm minus 2. Nm minus 2 is the unit. Okay, that's the meaning of stress. Okay, what's the definition? The perpendicular force applied on a force per unit area. If you want, you can add the internal perpendicular force. Perpendicular force. Please add this word. Perpendicular force per unit area generated inside the body when an external force act on it. Yes, the stress equal force applied on an object divided by surface area. Stress equal Fa or F over A, the standard unit Pascal or Nm minus 1. So Nm minus 2. Nm minus 2. Nm minus 2. Okay, that's the basic of the stress. Are you got? Understood up now? Okay, today I am only explaining basic concept. Basic concept. Next day mean day after tomorrow, no? Sunday. Yeah, Sunday we can start relationships. Among these basic things, relationships. Today we have limited time. Okay, this stress we can categorize into two types now. We can divide into two types stress. Stress divide into two types now. This is a basic concept. The perpendicular force applied on a unit area of any elastic object. Stress now mainly two types. Stress. The same thing divided into two types. Tensile stress and compressive stress here. Compressive stress. Tensile stress and compressive stress. Okay, the same thing as I explained earlier. The tensile stress means the stress as increase in the length. The stress as increase in the length, like this. Increase in the length. Increase in the length. Increase in the length. Length increasing. The length increasing. Okay, length increasing. That force we called as tensile force. Tension force. Tension force. Tension force. The stress due to tension force, perpendicular tension force on a unit area we called as a tensile stress, while increasing the length. I got, that's only difference. The compressive stress means the stress of any object while decreasing the length due to compressive force, due to compress force. Due to compress force, like this. This is a force now. The force we called as compressive force. Compress force. Compress force. Okay, that's only difference. The same equations, that's only difference. That's only difference. Type of stress, there are main two types, tensile stress and compressive stress. Tensile stress and compressive stress. Tensile stress generally generated by tension force. That's stretch an object. Stretch means length increasing, right? Length increasing. Okay, that's a tensile force. Length increasing. Tensile force, perpendicular tensile force divided by cross section area is a cross section or surface area is a tensile stress. tensile stress, very simple. Compressive stress, the generated by compressed force that's compressed an object and decrease in the length, like this. Compressed object. Perpendicular compressed force divided by cross surface area is the compressive tension. Okay, that's the basic part. Basic parts. Okay, now 32. No? Okay, I have another class 8. Okay, that's a basic part only our target. Apita me plastic run barrier. Okay, I'll give you one question and you can practice and come to Sunday class. Okay, question number 1. Mm, 5-meter length, 0.2 square meter cross section area, rubber string, given in the figure. Given in the figure. While applying 50 Newton external force, the rubber string length increased up to 5.002 meter. 5.002 meter. Okay, this is a diagram. Simple question. Question part 1. Question part 1. Calculate the extension of the rubber string. Calculate the extension of the rubber string. Question part 2. Calculate the calculate the strain rubber strain. Write down the stress type applied on rubber strain. Stress type. Fourth one, calculate the value of third part answer. Third part answer. Okay, that's the question number 1. You have only one homework. Complete this and let's meet Sunday, 8:30 a.m. Okay, very simply, I explained today what are the basic parts of mechanical properties. Actually, this is very simple lesson. Make a final part, Young's module, only Young's module, little bit advanced. That one also, if you understood well, you can easily score this lesson. It's simple, no? And comparatively, first lesson or other lessons, it's simple. Make අපිට තියෙන්නේ we have only two laws, Hooke's law and Young's module. Okay. Any doubt? And complete this. Complete that. Okay. Okay, good. Hi. Okay, let's do next week. My advanced question today I given for easy question only for practicing basic parts. Up made practice now. Sunday we can discuss advanced questions. Okay, and goodbye. Let's meet Sunday morning. You can take screenshot if you want.